Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and we're doing a data analysis guided project on the Netflix dataset. Okay? It's a very common dataset to start practicing with, and I had a little bit of help on this project, so I'd like us all to thank John David. Here's his Facebook, and here's his LinkedIn. Big thank you for helping me get this project ready and get it set up for all of us. Okay, so big thanks to John and looking forward to the next one then. So let's get started. So starting with importing our libraries, standard data analysis libraries here, but we're also going to use warnings. So I'm just going to go warnings dot simple filter and because sometimes, not very often, a lot more with the machine learning libraries, but sometimes with pandas, you get kind of some output that's not the best. Okay, so you just want to, it doesn't mean there's an error. It means that maybe things are changing in the future or they recently changed or one of those things. Seeing it once is fine, but when you're delivering your reports, seeing all these warnings are kind of, it's not clean. Looks a little bit messy. So it's good to get, I honestly usually get rid of those. I don't like seeing them. More than once is unnecessary. So the first thing we're going to do is we're importing this CSV file from my GitHub reservoir. So also I just have to load up any data, but here we're just going to import the data into my data set, and we got our standard Netflix data set. Okay. So one thing to do right before we get started on anything, we're going to change the color palette. And who wants to use the same colors? If you followed any of my projects, you know I like to be a little different. So here we're going to do plt.style.use, and we're going to use the BHM style palette. Okay. So looking at the shape of our data set, we have 8,807 rows and 12 columns. So looking at our data types, we got lots of objects in our data set, which is really standard. The Netflix data set is a good one to practice with working with non-numeric data. Okay. So here what we're going to do is first thing we get started, we're going to do describe, but because we have so many objects, what we're going to do is we're going to include all of everything. So counts and frequencies, and then standard min. Oops, you gotta spell include right. Yeah. And I'm just noticing this dot t. If you did it without this dot t, what happens? You get the standard. So here, this is kind of the standard way to see it. Dot t is going to transpose it, so flip it 90 degrees, or kind of turn it 90 degrees. A little bit cleaner one here. This works well when the column titles are a little bit longer here, so they can sit kind of flat like this. Okay, so we're going to do that, and then we see our column titles and looking at printing the duplicated values. Okay, duplicated. Okay, so here, what this is df.duplicated.sum. Duplicated is a true and false kind of Boolean response that we get out of that. We can sum that up for all of the true values, and we can see here that no row was duplicated, so we have 0 duplicate values, which is good to know. Okay, so checking our null values, we can see we have a lot of null values here. An interesting way, because this is not exactly a time series data set, but it is over time that we do have new releases for new. So it's not an official time series, kind of the classic time series data set, but it is happens over time. So there's a time series component to that. So it's an interesting way to look at the null values is, and this was actually John's way of looking at it. And I think it's really a great way of looking at null values. As we can see here that oh, I used it wrong, incorrect. So here, why this is not working is I did .core. It's going to be is null. So we want to put this into here. We can see with is null, what it's doing here is 1 is the yellow color. So you can see here. You can see very clearly where the null values are happening. You can see only one rating has a null value, but all the rest, director specifically has a lot. It would be interesting to see this kind of over time, see if there's any trend in over time. Just kind of put that. Okay, so let's look at the percentage of null values next, just to get a sense of, you see the number, but what is the percentage of quickly? you can see we do get 29%, well, basically 30% in directors, cast, country will have roughly 10, and then a few null values. So just highlighting those. So we'll do something to fill those just to make it a little bit easier to work with our data set today. So fill NA. Now, I always recommend typing everything out, but there's just some times where you're kind of going to repeat the same thing over and over again, and it is really good to build that muscle memory. But something like fill NA is something you've probably done a lot already, so it's okay to copy and paste that. So here I just filling in fill NA, I'm going to add the mode, and I'm taking you have when you're doing the mode, so it's filling an object, you have to it produces a string, and you just have to index it into the 0 position to have the true value to fill it with. And here we go. Okay, and then the next thing that we're going to do is we're going to do a heat map again. Here's heat map. And we're going to go with df.core. Let's see if we still have, or not core, just like I did last time, is null, and see if we have any null values left in our data sets. Ooh, I'm a bad speller today, so let's change this again. So heat map correctly. Okay, and you can see here we have no null values. Okay, so we got that all taken care of. So now on to the fun part, the data analysis. So starting with just looking at kind of to understand the difference between movies and TV shows, the balance of how much those appear. Okay, so we're going to do something a little bit more advanced where we use matplotlib to edit and add in this count value. Okay, so we have a count of how many times each type appears, but it can be very often that you want to know what the actual number is, just be a little bit valuable to understand. So what we do here is we're going to assign to AX, assign this object, our count plot of the type of movie. Okay, so the same row that we did here. It's kind of just a short form way to select the title. So dot type, and then data equals df, and we're going to go palette equals accent reversed, so R. What we're going to do, so the reason we assign this to an AX here, what we're going to do is AX.patches. And what this does is it creates a list essentially of all of the objects in your plot. Here we have just 2 bars, so we're going to iterate through both of those bars. Okay, so first bar is going to be patch, and then we're going to iterate through this and do this, and the second bar. Okay, so this will patches will take out all of the things, the lines, the bars, all the stuff inside. And so then what we want to do is as we get out the patch, the bar in this case, we want to annotate. And what we're going to annotate is we're going to get the height, and we're going to get where the X position is, and then get the height of that. And we're going to put basically essentially these two right here in, essentially put it on. It's very hard to get this exactly sitting on perfectly. I would say almost impossible. But it is a good way to get this little count, because the count really can be valuable. I hope one day Seaborn gets that. Well, you could just adjust this yourself, has it count on the bar, but one day. So here what I did just while I was talking and rambling, I filled in title and I filled in Y label to get the rest of this plot done, and now we get a nice little count plot. Yeah, so also be good, this is a good position or a good time to use a pie plot. Okay, so what we can do here is value underscore counts, dot plot kind equals pi, explode, which is going to separate them a little bit, gives a little bit of texture here, and then we can see we're also formatting the strings to be as a percentage. Okay, so nice here. I'm going through that, and let's run this and make sure. Wait. Oh, P plot, P-L-O-T, not P-L-T, P-L-O-T. Okay, there we go. So value counts dot plot, and there we go. Okay, so we got a nice, and it gives a good sense of the proportion of each one. Okay, so going into this one again. So here, we want to make this plot a little bit bigger. It just doesn't, the standard size of the plot wasn't very nice. I want to make it a little bit longer. So what I'm going to do is I'm going to do plt.figure, and big size equals 12. So width by height. So 12 width, 4 height. Okay. Then we're going to go ax equals to sns.countplot. So we're assigning this to the ax object again. We're then going to iterate through this again, just like we did up above. And we're going to go plt.title and then plt.xtext to kind of rotate that a little bit. Okay. So we get that nice little, I think it was a pretty nice looking plot right there. So what you can see though, when we go to the ratings, a lot of just ones that occur, a very small amount. There's some errors in here as well. And some really just kind of, I would think, errors, but some really values that do not occur a lot. And we could probably group these together a little bit better to have a smaller number of categories to better analyze, to better understand the data set. So what we'll do, we're going to create replace structure, essentially a dictionary. What this is going to do, we're going to be looping through a column. We're going to be applying this on a column. So what you're going to have is the value, and we're going to replace that with teens. And we're going to have the value in our dictionary and what we're going to replace it with, and so on. So these are just connecting these two together. And what we can then do is apply it on a column, and it will look for PG13, and for everyone that it finds, it's going to replace it with teens. Okay? So just kind of substituting each one of those. Okay, so that will really reduce and maybe hopefully get able to better understand this. Okay? And so we're going to make another pie plot right here. So first thing we'll do is explode. Explode. And what we're going to do in the next line, in the font title, so plt.title, we're going to change the font size to 22. And this one seems like a weird name to me, but font weight. Okay, so the font weight to bold right here. Okay, so really, really good job. Okay, so then we're running that, and then just looking at this is the same thing that we've done, the count plot, and then noting each one of the bars as we go through that with the actual count. Okay. Getting into the title. Okay, so what we're going to do is we're going to use WordCloud next, and really, I'm just kind of curious, I guess, to see what is the most common occurring word in the titles and stuff. I'm really kind of curious to see what that looks like. So what we're going to do is we're going to make a backdrop. So figure, and make the background to put this plot into. Okay. So what we're going to do is we're going to create a word cloud here. Oops, sorry, I got to import this first. So to import this, so from word cloud, import word cloud. So capital W, capital C, word cloud. Okay, then underneath here, we're going to use word cloud. And what you do is you give it a background color, width, and height. So what these are the pixels. This is how high definition it looks. This is not changing the background figure. That's what this was for. This is just to make sure it's high quality. If you don't use this, you'll see it gets a little pixelated and stuff. But again, that's just to change the quality. So generate the next one. So we assign that to a word cloud object. In our word cloud object, we're going to go dot generate, and we're just going to essentially join all of our titles to a string. So it's going to be essentially one big long string. And then what we'll do is we will im.show. So it's image show. It's a little bit different than our standard plot. But that's again why we're having this 15 and 100. Oh, we're name class. So here's a good error. I was a little bit confused at first because that looked right to me. But what you see here is name word cloud not defined. Silly, silly mistake here. What I did is I forgot to run this first where I import the word cloud and then I can use it. Okay. It takes a couple seconds to run as it's just iterating through all of the rows. And so you can see here, love is very popular, man, girl, life. And you can go really down. Power Rangers appears sometimes. There's a few Power Ranger movies, Ghost. And you can just get lost in this. Lots of fun. Okay. So exploring that. In the next one, we'll do the same thing, but we're going to do it now for the actor names. Curious what actor name appears the most. So we're going to do a plt.figure and then fig size equals to 10 by 8. Okay, here what we're going to do is background underscore color. Underscore color. And then we're going to go width by height. Okay. And that's going to generate our word cloud. And then we're going to, so that's going to create the object. then we're going to go WordCloud.generate and put all this here. What we're doing is we're just saying when it does not equal cast, or when we're changing cast to 0, we're going to add to the word cloud and then we're going to apply it. The thing is, if you didn't do this, the word cast appears in every single row. This is cast in the list of the cast members. So you got to get rid of it or it just will be the most common occurring word. Okay, so font, the next line, font in the title, font size equals 22, then font weight. So there we go. Doing that, and we get our common action. Run this, make sure it runs. Okay, and it does take a couple seconds to generate. And there we go. Get that one done. Now let's do our last one. Let's try and build one of these. So plt.figure fig size equals 10 by 8. And we're going to say word cloud. We usually do, I would say it's just a really good idea to do all your variables in lower cases. Uppercase, capital letters mean something in Python. So it's best not to use those unless you know why you're using those, truthfully, because it means a class, it means something more important than just a function. So it's just a variable. It's good to use it all as lowercase letters. Okay, so here what I did is I assigned this word cloud to an object. Then I'm going to go word cloud, my object, dot generate. And then I'm going to go plt.imShow, and I'll put my word cloud inside that. Okay, it's pretty. Word cloud now of the most common directory. So we see Michael, David, Lee were really common actors. Michael, John, David, similar but not exactly the same, were common directors. Kind of interesting. I just wrote some observations. And this is really important as you're going through, you're collecting your observations, and we're going to summarize them all in the end. Okay? So going through that. So what I did here, so just to highlight this. So I went value counts. If I don't do sort index, what it will do is do the one with the highest value counts and the next highest value counts. Now that's great. If I wanted to do this over time, though, it would make more sense to me to have this index sorted. I didn't give sort index ascending equals false. I just gave it to sort by index. So starting with the lowest number, and when you do value counts, the variables inside that you're counting appear a different number of times. So here what we're going to do, we're going to use this to show how this works. So here what we'll do is down below, we'll go value underscore counts, and we're going to do sort underscore index, and then we're going to do plot. Okay, so we sorted that because if we didn't sort this, let's see what this looks like if we didn't sort this. It looks fine, kind of all over the place, but here I think it looks a little bit better to sort it this way. Oops. So dot sort index. It makes it nice a little bit cleaner. And then, oops, I just need to put the parentheses because sort index is a function. And whenever you're using a function, you have to put the parentheses, even if you're not passing. The parentheses are what let Python know that you're calling and using a function. Okay, so there we go. Now the thing is this is very exponential, like we saw up here, the very small number and then a very large number that appear later on. And so it's very exponential. We can kind of flatten this out and see if we can gain any insights by looking at this with taking the log based on the y scale. Okay? So here what we're going to do in the next one, we're going to kind equals bar, fig size equals 16 by 5, and with a nice little thing about pandas is we can just do the fig size right inside the function. And then here we're going to do the special thing that we're going to do this time is share y, or sorry, log y. Log y. So loggy, I guess. And here, not any extra insights I was able to extract by this, but we can see here it does have a nice slow gradual gain, but really kind of, you can still see it drops off here. It wasn't as noticeable to me until I came over here, and so it goes up and then down. Is Netflix going downhill? I don't know. It's definitely producing a lot less movies now. It's in real terms, it's just a huge drop in new releases. And this is in 2021, so I'd be curious as to why that is. Okay. So going to the next one. So here, just looking at what the oldest movies are. So sort values by release year. But I'm not going to do anything. I'm not going to give it ascend equals true or ascending equals false because I actually want the lowest one at the top. Okay, so 1942 right here, we can see Prelude to War, The Battle of Midway, and Undercover: How to Operate Behind Enemy Lines. I don't know any of those movies. Maybe you do. Probably not. Those are, I don't know if my mom would know those. 1925, 1942 was quite a long time ago. Okay, so doing all those ones. Now we're going to get into understanding the genre and a few more things. And for once these next steps, we're going to need to do something called explode. So what this is if we look at listed in right here, we see that it is not is a list of them in there, but when we look at the value just as it is, we see this not a list. It is a list to us humans, but to Python, this is just a long string of letters and put some commas in there, but it doesn't matter. It's just a long string to Python at the moment. So what we need to do is we need to go str. So we're calling this variable dot split, and we're going to do this so that we can use it with dot explode in the next step. Okay, so right here. And you see now the only thing that happened in this step is that we split it on the commas, and everything looks the same. The comma is still there, but so we split it on the comma. But now it's not a comma in a string, it's a comma to separate different items in a list. And we can see this by the square brackets on that side. Very simple, but very simple, very easy, because the one problem with this data set is that this is unstructured or semi-structured data, in that we have a different occurring number of items in this list in each value. So it's not structured like a data frame that's square. This can't be square. All columns have different numbers of values. How could that work? So we need to change this into structured data. And so what we're going to do into a standard data format. And so we're going to do df.explode, and we're just giving it the column name that we want to explode. What this is going to do is create a lot of extra rows. So what we're going to do is I'm just going to assign this to a separate data frame, and then we'll work with that one for this specific analysis. Okay, so we run here, and when we run this, we can see that we get a lot more rows. So what's going to happen is for international TV shows, it's going to create a row for this movie right here, and then everything else will be the same, and it's going to create another row, and it's going to be TV dramas, and everything else will be the same. And then another row, and then listed will be TV mysteries, and then everything else will be the same. Now, yeah, you will be duplicating lots of the other values, so it would not be good to use df2 now to say do some other analysis because it would be duplicates of the other values. But what we can do in this value is we can now do a simple value count and see how many values there are. Okay, so what we're going to do here is we're going to go df data frame, and then what we're doing on the inside is we're going right here. So we're doing the inside, so df2 and then df2 type not equal to movie. So it just has the name of the movie listed in, and we're going to go with the value count. So we're just making sure that it doesn't have, we're not looking at the movies here. This is just the TV shows here, and then we're just going to look at it. So you can see here we got quite a few movies right here. 20,000, or sorry, 1,300 in this. And then that's good. If we want to see the percentage of movies that are occurring in each one of these, what we could do is dot or just sum. We're just going to sum this up. So we're going to sum up all the values in this whole series, this value counts right here. And then if we divide this whole this thing that we see right here by the total number, what you do is give us a percentage. See here now there's 20% in this one, and so we're going to do the same thing on the next one. We're going to do pd dot data dot none. So pd dot data frame. So we're going to put the same thing, and that's why we're doing this dot head on the end. After we put it into a data frame, something nicer to look at, we're going to go dot. Okay. The same thing. We're going to sum up all these values, and then go into TV shows. And see, we get the amount of times international TV shows occurred 22%. Well, movies only occurred 20%. You can start analyzing this in more detail, and I wrote some specifics on here. Okay, so getting into columns now, looking into how movie changed by the decade. So the thing is we don't have a decade column. So to break this down into decades, I had to create a little function that we'll use with dot apply. Okay, so I go get decade. I'm going to change the value into a string, this integer into a string, and I'm going to index and just get the first three values. So these first three values, and then what I'm going to do is add on to the end 0s, so decades basically. And you can see now we get this column instead of 2020, 2021, we're just going to get 2020s, 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 and so on, 2010s, 2000s, and all of that. So then what we'll be able to do in this next one is we'll be able to go G is equal to S&S facet. Okay. And what we want to do is sort underscore values by decade. And this is helping making sure everything appears nicely. We want our columns to be decade, and we want share Y to be false. So they all have kind of. If you didn't do this last one, oh, I gotta do the second part. So then we gotta go. So after we set our grid, we make this grid. We have to go and say what we want to put inside it. So then we go g.map, and that's our count plot. Okay, and it's really, really interesting. TV shows were always more popular, but here you can see that movies in the 2000s are so much more popular. And then in the 2020s, they're kind of equally popular. So I'm very curious to see what happened from the huge huge change from TV shows to movies and why that kind of flip-flop back and forth in these decades. Kind of interesting to understand what that happened. Kind of interesting to notice that pattern as well. Be interesting to see these by month as well. So what we're going to do is date time, all lowercase, and then index. So date time, capital D, index, capital I. And we don't really care about this. What it's going to do is change it to a date time value. But what we care about is we're going to get month. We're going to get the attribute, the month value, and assign it to a column. So if we run this, it's going to change it to a date time column, and then but just extract the month, and we're going to assign it to it. So we got 1 to 12 right here. In the next one, what we're going to do is we're going to do sns.countplot. And then we're going to do our iteration through the patches as well to put the bars on it. And then we're going to go, so we're going to assign this to G, and we're going to go for P in G patches. So for each one of these bars, we're going to go G.anote, and we're going to get the height of the bar, get, and get. So get the height of each one of those, so we know where to put the bars, or the little, sorry, not the bars, the numbers on the bar. Okay. And so the next one, what we'll do is we'll do hue equals df as the type. And so we're going to break this up. Now you use same thing here, but now you can see, although it seems like July is the most popular overall, really we can see here, July is the most popular for movies, but for TV shows, it actually seems like December is the most popular. Very, very interesting. And I can't really explain why that would be, but just again, we're seeing all that. Data analysis. Maybe you can figure out why that, or have a good theory as to why that happens. Okay. So we're going to do this next thing. We're going to do the actors next. So we need to do the same thing because the actors come in a list of actors. A different number of actors in every movie. So we have to do the same thing that we did. String.split, str.split, and we're splitting on the comma, just like we did up above. And then we're going to go on the df, the original df that we did, we're going to go df.explode to assign this to df3, just to have another variable to run this to. Okay, and then cast, what we're going to do. So what I'm going to do here is I'm going to do value counts, and then I'm going to take the index. Okay, so it says actors, and it says the list of the actors afterwards. So I just wanted to select from the second position index, not the first. So from 1 to 11 to get the top 10, because the first one is actors. So I'm just avoiding selecting that one. And then what I'm going to do in the next one, so I create a list of the top actors, the top 10 actors. You can change this if you want to make it bigger. We're going to then logically index by list. So we're saying data frame, data equals data frame, and then logically indexed by the cast is in the top actors list. So when it's in those, we're going to logically index by those. We're going to order it by the top actors as well, and so make sure it's in the same ordering from higher to lower. And we're going to change our palette to be rocket. Okay. So let's run this one. got another one there. Okay, so we're going to do now the same thing again for the top directors. So we're going to go str dot split. Okay, so we're going to split, and then as you guessed, we're probably going to do explode on the next one. Okay, so in the next line, now getting the top directors that we did up above, we're going to go value counts dot index to get the index values, and we're just going to select not the first one like we did last time. We're going to miss it because it says director is the most common occurring one, and so we're just going to avoid selecting that, and then 1 to 11. So the second position to the 10th position. Okay, so then what we're going to do in the next one, we're going to go SNS dot count plot, and then data equals is logically indexed data frame by the top director. So only with the top directors occurring, and then we're going to do hue as director. Okay. This first one. Always forget to run the cell above. Got to run them as we go through, and got to spell count correctly. Can't believe I forgot how to spell count. Oh, sorry. Not supposed to be here. That's supposed to be X. Okay, because we're putting the directors on the X. So apologize. I was looking at that graphic and it kind of changed the colors. So I was thinking hue, but it is actually X, I think. And it just automatically changes those colors once you count once. Okay, so we'll do one last, I think the last thing for today. We'll do now the same thing on the country. Okay, so we split this. We're going to go explode. So let's make sure we run these cells as well. Learning from what we did before. We're going to avoid no country because that occurs a lot. So we'll do the same thing here when it's no country, because it does not occur the most often. It occurs quite a bit, but it's not the first one. So I couldn't do that little trick that I did before when I'm selecting the second to the 10th position. I'm going to select here from the first to the 10th position. So selecting everything up to 10, so 0 to 9, first to 10. Okay, so I'll run this one, and then what we're going to do is we're going to put this top country variable inside is in top countries, and then order by top countries as well. Okay, and you can see, no surprise here, really truthfully, how much more movies are produced by the United States. I was actually surprised to find out how much is produced by India as the second position. And Canada, I'm actually surprised that we're up there fourth, truthfully. I would have thought Canadians, we have some movie industry, I guess. I wouldn't have thought it was that big, though, if I'm honest. Okay, so there we go. And that's it for our project. So we have all of the summaries. So what I did as we were collecting those observations, all I do is I copy and paste them as easy as it can be in our summaries right here, and kind of going through all of the things that we learned. I left this code right here. You can run this and it will save your projects as a PDF as well. You have to make sure that you mount your drive, or if you're using it on a Jupyter notebook, it will just automatically create a PDF from this file. Okay, so thank you so much for joining me today, and thank you again for John and all of the help you did in putting this together, and I will see you all next time. Bye.